Hello everyone, I am Pavni and today here we are discussing about decision trees and machine learning. Yeah. What is decision trees? A decision tree is a machine learning model that makes predictions by asking a series of yes or no questions like a flowchart. It is a simple definition, right? And the actual definition is a decision tree is simple and powerful tool used in machine learning to make predictions. Every algorithm in machine learning is used for to make the prediction, but what is decision tree is different for. It is mainly used for classification, like to detect whether the mail is spam or not. And also, we have to use this in regression, like predicting the house prices. And we have already some questions like, is it raining? If no, we have to proceed for the task that we have to do. Is it sunny? If yes, go for the picnic. If no, we have to go anywhere. If it is not sunny, if it is warm, yeah. If there is any decision type which is if it is fine, we have to do that particular work. If it is not, we have to do not. And decision tree work in the same way. It asks a series of yes or no questions about your data, leading to a final decision or prediction. Yeah, actually, with the example that we are seeing, it is also used in the classification and the regression itself. And why these decision trees are useful? Because of using these decision trees, we use this in a very understandable manner. And why? Because these decision trees look like a flowchart. So we can easily understand by the visualization of the chart, and it is very flexible, which means that we have to work on both the numbers and the categories. Numbers include the age, income, digits, and the categories includes color, type, height, and these are all the types. And it can be access handle complex patterns. Yes, and no need for the data scaling. It don't need to normalize the data, it actually do. And the real world examples how where these decision trees ought to be helpful. And suppose you are a doctor diagnosing whether the patient has a disease or not. You have to find whether the patient have disease or not. And how we are confirming by asking some questions, right? What is the patient's temperature, cough, cold, headache, and if is a patient is fatigued, and these are all the things that the questions that generate be asked by the doctor to the patient, and based on the questions answers that the patient is to be said, that doctor can be categorized whether the patient is to be in a normal condition or a severe condition. Example, if the patient temperature is 100 degrees Fahrenheit, yes or no. If is, if he is a cough fever, yes or no. If it is no, there is no disease. If it is yes, there is some disease. And the patient's temperature is not temperature greater than 100, then if the patient is fatigued. If yes, he considered as a disease, if no, have this. And these are all the things that the doctor needs to be characterized, and in that type of series, we use this decision trees. And how the decision tree it will be structured. And in decision tree, there are four main nodes. First one is the root node, which is the starting point of the decision tree. And the internal node, leaf node, branches. Internal node is the node which is asked by the questions that have to specify about that particular feature, which means that as we previously asked it the question, is the patient's temperature greater than 400 degrees Fahrenheit? Is age greater than 30? And these are all the types that we have to include in the internal node. And leaf nodes, it is the final answer. If if yes, we have to consider the final output. It is in the leaf nodes. And in the branches, it is representing the connection between the nodes. Either it may be root node to internal node or internal node to leaf node. And it is the structure of the decision tree. And how these decision trees are to be worked. Yeah. And the tree that splits the data, smaller groups, and the future values like age and the temperature. It is divided into small groups, and each one with actual splits in the group as pure as the possible, meaning they contain in the similar output. That is like spams, emails that is all in one group and not spam in all another group. And these are some of the applications for the decision trees methods. That is medical diagnosis. We can use the decision trees in the medical diagnosis as we or discussed previous, and the finance, which is to access the credit risk with a borrower repay a loan or not. If he is not, we are not giving him loan anywhere. And if it is due, we can give the risk without any risk. And marketing for predicting the customer chance. How will the customer leave or will the customer continue the work? Or these types of applications and the recommender systems such the products based on user behavior. And these are all some of the applications for the decision trees and how these decision trees will be work. Like based on the decision tree splits the data into groups, and the goal is to create groups where the points have similar outcomes. Now I'm just going to run this cell, which is the step where I just importing the things uh, for furtherly we have to use. And now we have to see that how these decision trees make decisions. And we can see that the decision trees are recursively splitting data into smaller groups based on the feature values, right? If it is one category, it moves to one from based on the node. If it is not, it will be moved from the another branch. And these are all the things. And evaluate the split categorization like Gini impurity for classification. And these we have to repeat for each group until its topic condition max, like a max step, pure not, and what they actually do. And assign a class for the classification, average value regression to each, and splitting criteria, and how these nodes ought to be splitted. To decide which is the best question, the algorithm use a mathematical measure to evaluate how good the split is. And the goal is to make group as pure as possible. Why? Because based on this categorization, our whole decision trees ought to be measured. And here are some main criteria. That is Gini impurity, entropy, mean squared error. And how we have to calculate this Gini impurity is actually this Gini impurity is to be measured how often a random chosen simple would be misclassified, which is based on the error state. And the formula for this Gini impurity is 1 minus summation of p I power square and p underscore I, which is nothing but the proportion of the class I in the node. And for example, if a node has 50% of class A and 50% of class B, and lower Gini impure means a purer node, means that which one have the lower Gini, we have to move to that side. So, okay. And this Gini, which is used by the sklearn dataset, sklearn library. And the second one is entropy and information gain. Entropy means measure the randomness or impurity of a node. When we have to calculate the entropy, it only chooses how it measures the randomness of that particular element, and which is also to be categorized how much impurity in a node. And the formula for this entropy is minus summation of p underscore I into log base to p of I. And we can consider pi is a proportion of the class I. And for example, this entropy, which means that if a class has 50% and 50% of class B, then we can consider the entropy, which is indicates higher entropy means more randomness. And the information gain measure how much entropy is reduced after a split. Actually, in the decision trees, we have to split those ends, right? And this information gain is only considered how much entropy is reduced after a split. For that calculation, we use a formula. Information gain is equal to entropy parent minus weighted entropy of children, summation of weighted entropy of children. And in the feature is the highest information gain is chosen for the split. And which one has the highest information gain, then we can consider which is the best split and we have to move to that split. And the third one is mean squared error. And for the regression, the goal is to minimize the variance in the target variable, right? And for that, we use the formula that is mean squared error is equal to 1 by n into summation of yi minus y hat power 2, where yi is target value and y hat is the mean of the target values in the node. And these are all the things that we are how the decision tree is to be splitted in which category. And to build a decision tree, first thing we have to start the entire dataset at the root node, and we have to choose the feature and threshold for the best split the data. And we can split the data into two or more subsets, and we have to repeat for each subset until a stop condition is met. And where the stop condition is to be met, maximum tree depth reached, minimum number of samples in a node is pure, means that all samples belonging to the same class or having same values. Then the type of place we use this node is pure. And these are the three types where it actually been stopped. And we have to assign a class for the classification or average value to each leaf node. And there is one stopping criteria where it would be stop. Actually, we were discussing right now, right? Maximum depth, minimum samples per split, minimum samples per leaf, maximum number of nodes. And these are all the stopping criteria where it rises to complex trees that overfits our model. For example, suppose that if in a dataset 10 fruits with features like red and orange and small and large size, and the root node is color red, okay, it will split in one case, and the left branch is split in if it is larger, okay, leads to mostly apples, right? And in the right branch, not red, mostly oranges, so no further split needed. If the leaf node has as an apple or orange based on the majority classes. And this is one example that where these decision trees methods are to be have. And let's take a program, example program, then how based on the iris data set. Uh, and here I just load the iris data set, and here I take two variables x and y to fetch the data for x variable and to make the target of how what the things like setosa, vesicle, or vigenica, and these are all the things. And now I just want to convert to the data frame. Now DF is the thing that we actually been imported and data frame, right? And for the feature names, we just make the target values to the y and display first five previews. And now we can split the training and testing data, as we actually know that 70% is for the training and 30% is for the testing. And we use this syntax x train, x test, y test. It is the syntax to train, test, validate the model. For splitting the data into train and test folders. And now we are going to training the shape and the test data shape, how it would be look like. Now we got the output as data set preview, which is the training data shape, which is 105 comma 4, which has x has 105 and y has 4. And for the testing data set, the shape would be 45 comma 4. And these are all the things about the decision trees. And now coming to the methods of decision trees, there are it would be applied in various ways, like classification decision trees, regression decision trees, pruning, ensemble methods, handling missing data, feature importance. And these are all the things that are comes under methods of decision trees. And first, let's come up with classification data decision trees. And the purpose for the classification decision trees is to predict categorical outcomes. Categorize means it is, for example, it is email is spam or not. To whether check the email is spam or not, we have to consider this decision tree and how it works. It splits the data based on the features and it calculates the Gini impurity or entropy. It would be splits. And the output, it should be leaf node essence to a class label, whether the data set is spam or not. And there is some in the examples like classifying iris flowers into Setosa, versicolor, and virginica. These are all the types in the flowers. And the second one is regression decision trees. And these decision trees are to predict continuous outcomes like house prices, temperature, which means that it's not a particular uh, number, which means that 0 to 2.5, 36 to 100, and these are to be called as continuous data elements. And for that, we use the regression data sets and how these works and splits the data to minimize variance. MSC means mean squared error in the target variable, and what the target variable that we choose, which have to minimize, which have to splits the data just for example, it used mean squared error as well, and for the output, each leaf node assigns the average value for the target of the node. And for example, in the regression decision trees, predicting a house price based on size, location, and number of bedrooms, and these based on consideration whether the customer have to know whether the house is to be worth to buy or it's not. And the third one is pruning, as the decision trees can grow too complex, fitting noise in the data overfit. That type is to be called as pruning. And for the solution, pruning specifies the tree by removing unnecessary branches. If there are many branches for the small dataset, it is not unique, right? So that for that purpose we use pruning, and in pruning there are two types: pre-pruning and post-pruning. Pre-pruning means stop growing the early tree by setting limits. Post-pruning means grow the full tree, then remove branches that don't improve accuracy. And these are the two types in the pruning, where when the decision trees are going to the more complex, it should have to fit the data. In that particular process, these decision tree method is also to be used. And ensemble methods. And ensemble methods is nothing but can overfit and unstable data. Small changes to different tasks. Ensemble methods combine multiple trees to improve performance. It can be useful in random forest, gradient boosting, ada boost. And in random forest, which is extension for the decision trees, which builds many decisions on random subsets or features. And also, it aggregates predictions, majority voting for classification, averaging for the regression. And the benefit of this random forest, which reduces the overfitting, improves accuracy, and handling noise data. And gradient boosting means building trees sequentially, where each tree corrects errors of the previous ones. And ada boost means combines weak learners or weak points to gain more weight. This is multi-class samples. And the fifth one is handled missing values, and which is also one of the method in the decision trees for missing the values. And for that, we have to make the solution, that is scale and learn requires you to impute missing values. We have to replace those mean and median values before training the datasets. Advanced library like XGBoost can handle missing values by assigning them on a branch and minimizing loss. And the future importance for the decision tree methods is to make feature combinations to predictions. And this to be work based on to reducing the Guinea impurity across splits are considered more important. And the advantages for these decision trees is interpretable, no feature scalar, handles non-linearity, and versatile. And the disadvantages for these random for decision trees is overfitting, which can over memorize training data, and instability, which means small change of data can make the flow completely different. And bias towards features with many categories, which means that features with more unique values may dominate splits and not great for continuous data, which is used for the small data itself. Improving decision trees. And we have to improve these decision trees by assemble methods, apply pruning, tune hyperparameters, and balance the datasets to avoid bias towards majority classes. And here is the sample program. Then how these decision trees is to be work. And the decision tree classifier, which is a method that is already been defined, which can automatically calculate Gini and max depth splits and all these things, right? And we can make this fit into X trend, gamma y trend, and then we have to make the predictions, and we got the accuracy score. And for the classification report for the iris datasets, and we can visualize these decision trees like this. And now, based on this true or false, we got the decision tree and how this class to be versicolor or setosa or Vajnika. And this is all about the decision trees methods.